last day of Learning Target 11, we're going to take a look at some similar figures. What those are figures that have the same shape, but not the same size. So if you look at my example here, we've got these two right triangles. One's bigger than the other, but you can tell that they have the same shape, so they are called similar. What does that have to do with proportions? Well, if we're solving for a missing side in similar figures, the sides are proportional to one another. What that means is that there's some sort of scale factor that when I multiply it by all of the sides in one figure, it will equal all of the side lengths in the other figure. So what do we do with that information? All right, well, we start by determining which sides are corresponding in our two similar figures. What that means is that it's kind of the same side in the different shapes. So when we're looking at these, our figures, our trapezoids here, have the same orientation. So therefore, 3 is a corresponding side to x, and 4 is a corresponding side to 6. Once we know that information, we set those up as ratios equal to each other to get our proportion. So what I said was 3 corresponds to x, and 4 corresponds to 6. Now there are lots of different ways that you could set up this proportion correctly, but there are a couple of ways that you could set it up incorrectly. So notice in my numerators, I've got 3 and 4. They came from the same shape. And in my denominators, x and 6 came from the same shape. So make sure that you're keeping your numerators and your denominators consistent, as well as each ratio, that 3 corresponds to x, so they're in the same ratio. All right, so now we solve our proportion. How do we solve proportions? Well, this one, my x happens to be in the denominator, so I'm going to start by flipping my ratios. Because what I notice is that there's no relationship, or there's no nice relationship between 3 and 4. So to solve for x, I'm going to follow the golden rule, multiply both sides by 3 to cancel on the left-hand side. On the right-hand side, I do have some common factors with 6 and 4. What goes into 6 and 4? 2. 6 divided by 2 is 3, and 4 divided by 2 is 2. Multiplying my numerators, 3 times 3 is 9 over 2. So the side length, x, is 9 halves. Let's look at one more where there's the same orientation. This time, my side length is an expression, g plus 2, not just a variable. But the process is the same. So figure out which sides are corresponding. So I've got g plus 2 corresponds to 5, and 10 corresponds to 4. So again, notice that g plus 2 and 10, my two numerators, came from the same figure, and 5 and 4, my two denominators, also came from the same figure. Well, this time I've got my variable in the numerator, so I'm just going to go ahead and solve by using that golden rule, multiplying both sides by the denominator. I'm going to cancel my 5 first. And again, this time 10 and 4 have common factors, so I'm going to divide them each by 2. On the left-hand side, my 5's canceled, so I've got g plus 2. On the right-hand side, 5 times 5 is 25 over 2. How do I finish solving for g? Subtract 2 from both sides. Now remember, subtracting fractions, I have to have a common denominator. You can think of it as subtracting 2 over 1, so my common denominator is 2. I'm going to multiply this by 2 over 2, and g equals 21 halves.